Okay, so we have the basic idea about how to determine the load or the demand. Then we are ready to size our solar array. This slide shows you the typical solar electric system. So actually this is a simplified one. First of all, we have the sunlight, and we can determine the peak sun hours from other online resources. And then we have installed some solar array and with some peak output power. And then there are some systems including a charger, cable, and also some inverters, etc. And finally go to the load. And the important thing is that every equipment, including the cable, has losses. So we have to take that into account. And this slide gives you a brief review on peak sun hours. Remember that the peak sun hours is a way to measure the insolation. And it represents the available daily solar resources. And the unit is hours per day. And how to calculate that? We can actually calculate the output power generated for a day in a square meter, and then normalize that by the unit that called 1 kilowatts square meter, and then we can get the PSH, peak sun hours. And this slide shows you the average peak sun hours in Taiwan, and you can check that from Global Solar Atlas. And for Taiwan, because the latitude, so the peak sun hours may ranging from 2.56 to 4.11 hours. So it's not quite high compared to the tropical area. How about the system loss factors? Okay, so this slide shows you a system, and that you have PV connected to some cable, and we have some charger, inverter, battery, etc. So what are the system loss factors? The first thing is it depends on manufacturer tolerance. So some solar cell may have some more losses compared to others. Temperature. In the previous lecture, we talked about the temperature will degrade the performance of the solar panel. The higher the temperature is, the lower the efficiency. And dust and dirt and dust. If there are some dirt and dust on top of the panel, of course the efficiency will be degraded. Cable losses due to resistance, and also the efficiency of charger, controller, inverter, and battery. Finally, there may be some mismatch between a solar panel and load due to non-usage of charger, controller, or inverter. So have those information, then we are ready to calculate the size of the array. First of all, we can come up with this equation. We can say that the load, actually that's the demand, is equals to the peak sum hour multiplied the peak or the maximum output power of the solar array and multiplied by the loss factor. So use this equation, we can determine what's the maximum output power needed to generate from the solar panel. The equation is equals to load divided by the system loss factor times peak sum hours. And after we come out with the maximum output power, then we need to determine what kind of solar panel we are going to purchase. And then we have, if you have the maximum output power for those panels, then if you divide the overall power by the output power for each panel, then you can come up with the number. Of course, the number has to be integer. So let's use an example to do a basic calculation. So here, if we have an off-grid PV system, and then the location is in Taipei area, and then we assume that the annual average PESH is 3 hours, and the annual consumption is about 7.2 kilowatt hours. So if you divide it by 365 days per year, then you can get 19.7 kilowatt hour per day. And then you may have the peak load. The peak load means that maybe you have a lot of appliances running together. So you end up with a large power demand. So this example assumes that there are panel losses, and we assume the number is 85%. And losses from the inverter are 95%, and the battery inverter losses are 95%, and battery efficiency losses are 85%. And the cable losses under standard testing condition is around 5%. So if you multiply all the number all together, you will end up with the overall loss is 0.62. So to cover those losses, you need to generate more powers. So we can calculate the DC power needed. We can use the previous formula. We have the daily consumption in the unit of kilowatt hour divided by the system loss factor, and then multiplied by the peak sum hour. And then finally, we can calculate the overall capacity. So in this example is 10.6 kilowatt. Actually, that's for the maximum output power. With this number, we can calculate the solar array size. So first of all, we need to know what kind of panel you are going to use. So in this example, we use the solar panel from manufactured by Jintong, and the module we choose is 280 watt. Okay, so here shows the number, and the other number is we can check out the open circuit voltage. In this case, is 38.08 volt. And the other information is the maximum system voltage, because a lot of panel will connect in series, but this data sheets show you that the maximum voltage cannot exceed to 1000 volt. So with this information, we can calculate the number of panels. Since each panel have the 180 watts, and then the overall power needed is 10.6 kilowatts. So if you divide that by 0.28, you will get the number, which is 37.8. But remember that the number of the solar module has to be an integer. So we round up to 38 solar panels. So if you connect all of them in series, so multiply this the open circuit voltage, which is 38.08 by 38, and you will get the voltage which is higher than 1000 volts. So it cannot be connected all in series. So we can divide that into two strings in parallel, and each string will connect 19 of the panels in series. So now we have the idea of how to calculate the size of the panel. But the problem is that we have budget limit. Recall that in the previous lesson we talked about the initial cost for the solar system, which is about 3.18 per watt. So if you have budget limit, it may not cover all the power demand. Of course, there is a space limitation. Typically, it will require 15 square meter for 3 kilowatt hour capacity. So, for example, you are going to install the system on your rooftop, then you have the space limitation. So, after you determine the energy needed annually, you need to take the budget and space into account.